Hey guys, welcome back to AlgoYogi. Now we are doing array and hashing series. Our next problem in the list is longest strictly increasing or strictly decreasing subarray. So we are going to LeetCode and then let's read it out. You are given an array of integers called nums. Return the length of longest subarray of nums, which is either strictly increasing or strictly decreasing. So here we are given basically the array, and we need to return the longest array, which could be either strictly increasing or strictly decreasing. So let's switch our view. Here I've taken the first example. So what we are given is just an array. Then we need to basically check the length of longest subarray that is either increasing or decreasing. So what we can do is, how about we do one by one. So let's say I just want to check if I'm checking for strictly increasing array. So what I'll say is longest length in the beginning, I will just say it's nothing, it's 0. So I'll just say longest strictly increasing length basically right now is 0, and then I'm gonna start visiting this array basically. So for I in range, let's start with 1 and go up to n, where n is the length of this array. So I'll just assume that n is, not assuming, let's just calculate it, nums, right? So now I will check for this right now. What I'll do is I will check current length is also 0. So here I will check actually current length we can just assume 1. All right, current length we can assume 1, and then we'll check from the first index that if this element that I'm checking at ith index, so if nums I is greater than, because it's strictly my previous number, which is nums I minus 1, right? If that's the case, then my current length I can increment by 1, right? Otherwise that means I'm seeing either an equal number or a number that is bigger, or smaller, or is a number that is equal or smaller. But we are trying to look at strictly increasing pattern. So that is why I will reassign this whatever current length I have updated so far. I will again go make this to 1, and then basically keep processing them. So what's really happening here is we are incrementing this current length as we are going forward, and we are incrementing it if we are seeing a number that is greater than its previous number. So this will keep incrementing its count, but we need to update this longest strictly increasing value, the length. We only care about length. So what I'll do outside these if else, I will basically update this, or maybe there is no, maybe there is a need. Yeah, there is a need. So here I will update this with LSI is going to be maximum of LSI or current length, right? So that's what I will do now, and then finally I can return this LSI. However, it's not just longest. We have processed longest strictly increasing, but now we're going to process longest decreasing. So the same thing that we are doing here, same thing that we are doing here. We can do that for one more time for basically longest LDI, so longest decreasing one, and then out of these two we can return the maximum one. So I can even write that right here. However, why don't we include that? We can also include that part in this code as well, because at the end of the day we are processing all of these values. Then I think we will right now we are taking care of just this one with if and else, but I think it's okay to have two for loops, check for longest increasing or longest decreasing. So right now I think that would be the best approach, but I think later if you can concise the code, please do it. But I think that's a good approach what we have just discussed as well. And here the time complexity, because we are doing this twice, once for longest, you will do the same thing. And you know what, I'm just like motivated right now to show you guys how the other for loop will look like. So the same thing right here that we have done, we will do this, we will do the same thing, but we will change LSI to DSI, sorry, longest decreasing increasing, longest decreasing, so LD, longest strictly decreasing, LSD. Sounds bad, but sounds like a drug. LSD is a drug? I don't know. But anyway, here also we'll do the same thing, and we'll update this LSD to maximum of LSD, and here what we want to do is we will check if the number, that current number, is basically smaller than the previous number. If that's the case, then we will keep incrementing our current length and then update the LSD with the current length, and then finally you will return max of LSI or LSD, and here the time complexity is going to be big of n or n plus n, and space complexity is going to be constant. You're not using any space. So let's write down the solution now. It's an easy peasy solution. I'm gonna switch to the view. All right, so as I said, we're gonna have L longest strictly increasing right now is 0. Current length is 1, and for num, or I'll say for I in range 1 till length nums, and if nums I is actually greater than nums I minus 1 from the previous number, that means we are strictly increasing. So that is why I will increment my current length, since I just found a greater number than the previous value. Else I would reassign this value to 1. That's because I'm including the current number, in that count, and I will update the LSI with maximum of LSI, or the current length. The same thing, as I said, same thing we will do again for LSD, and here were the few things that we changed, and that's it. And this one, LST, longest strictly decreasing, LST. And finally we can return maximum of LSI LSI or LSD, right? That is it. That is our entire solution. And of course, you know what? That's your homework. If you can, merge these two for loops, make them one. However, it will not change the time complexity or space complexity. They will remain intact. But, you know, please merge them together. That's your homework. Well, anyway, we are done. So no. Let's test this out, because this is the first time I haven't solved this problem before. So I'm gonna test this. So let's test it. And yeah, okay, you can see like I've not solved it right here. You can see, and for basically, it's asking, you know, output for nums 1 if nums length is 1, you know, if len nums is actually equals to 0, you know, or len nums is equals to 1, then we can just return the length, right? Length of the nums. All right. So now I think this edge case that just remained there will be satisfied. All right. So that is our entire solution. Now we can write down the time complexity. This is the best solution, honestly. Time complexity. Complexity is big of n or n plus n, same thing, 2n. And space complexity, we haven't used any extra space, so we'll say big of 1, constant. All right, that was all. Let's go to AlgoYogi, mark this problem solved. See you guys later in the next. How did it? I fixed that problem. I fixed that problem in my app. There is something when this updates, it sends, you know, it updates the parent, and parent sends another, you know, unchecked state. I thought I fixed it, but actually I didn't. So anyway, I will fix it later. See you guys later in the next problem. Until then, bye.